How's it going, everybody? Today we're going to be talking about an extension of the quadratic formula. It's analyzing the discriminant. Now, the discriminant is an opportunity for us to basically foreshadow what kind of solutions we should expect when we solve for quadratics. Now, just to remind everybody where the discriminant is located, the discriminant is found when you're looking at the formula. It's found inside the square root, this guy right here, okay? Now, when you analyze this right here, you can actually figure out what kind of solutions you're going to end up with. And it can be helpful when you're doing time tests and things like that, because it can sometimes basically eliminate answer choices, even though you feel like you didn't get answers that match up with A, B, C, or D. So it can be useful when taking tests. It can help you be a smart test taker. So let's kind of figure out what the discriminant can tell us. It can tell us 1, 2, maybe 3 things, okay? So it can tell us 3 things. The first thing it can tell us is if we have 2 real solutions, okay? Now, the way that looks is if you have something like this, and let me go ahead and shrink this down to size. We have b squared minus the 4ac is going to be greater than 0. That's how you'll end up with 2 real solutions. Then there is one where you'll get 1 real solution, okay? And that's when you have your discriminant, okay, where your b squared minus 4ac is actually going to equal 0, okay? So if it ends up zeroing out, you'll have 1 real solution. And then last but not least, you can end up with 2 imaginary solutions, okay? And that is when you have your discriminant is going to be less than 0. Now, you will not ever have just one imaginary solution. You'll always have 2 imaginary solutions, okay? Now, let's take a look at some examples. So some examples that highlight the 2 real solutions would be something like this. We have an x squared minus 6x plus 8 equals 0. Remember, a is 1, b is negative 6, c is 8. If you plug all this into the formula, you'll end up with negative 6 squared minus 4 times 1 times 8. Now let's go ahead and solve. So we have negative 6 squared is 36. Negative 4 times 1 times 8 is going to be a minus 32. Okay? Now, 36 minus 32 is going to go ahead and give us a 4. And 4 is going to be greater than 0. So thus we have 2 real solutions. Okay? So this right here, you can expect 2. Now, let's take a look at another one. Say I have x squared minus 6x plus 9 equals 0. So a would be 1, b would be negative 6, c would be 9. And so this is going to give me a negative 6 squared minus 4 times 1 times 9, and we'll see if it equals 0, okay? So this one right here is going to be 36. Negative 4 times 9, that's also 36. So this one is equal to 0. And if you equal to 0, this will give you 1 real solution. Okay? So the idea here, ladies and gentlemen, is that this doesn't tell you what the x-intercept is. This is just telling you you can expect only 1 x-intercept. Or you can expect 2 x-intercepts. And then this last one, you can expect no x-intercepts. You'll expect that it will never cross the x-axis at all. And we'll see what this looks like. So this is x squared minus 6x plus 10. And so we have a is 1, b is negative 6, and now c is going to be a 10. So we have negative 6 squared minus 4 times 1 times c, which is 10. That's going to be 36 minus 40, okay? And so we end up with -4, and -4, of course, is going to be less than 0. So this is 2 imaginary solutions. And this is the instance where it'll never cross the x-axis. It'll either be above the x-axis or below the x-axis in terms of where the graph is. So it'll either look like that or it'll look like this, okay? It will never cross the x-axis at any given point, okay? So just be aware of that, and that right there, ladies and gentlemen, is analyzing the discriminant in a nutshell. Let me know if you have any questions. I'll see you guys later on today. Alrighty, bye.